Well, this is kind of an interesting exercise we've been doing. This is called Where is the Cat and the Rabbit? This is really a DNA profiling exercise, and the story kind of goes something like this. I've been doing an experiment where I've been breeding rabbits, and I have a special female who I need to be bred with a special male. And I asked my assistant to go put the male rabbit in the cage with the female, and he went ahead and did that. And I came in a few minutes later and I realized, oh my gosh, he put the wrong male rabbit in there. So I quickly grabbed that guy out of there and I replaced him with the correct male rabbit. And a little while later, we separated them, and eventually we had baby bunnies, and we analyzed them, and we thought everything's going okay. But then I realized, you know how rabbits are. I wonder how long it really took, and who was the real father of those bunnies. So in order to figure that out, I realized I had to go ahead and take some DNA from the mother rabbit, and I had to take some DNA from who I thought should have been the correct breeding husband rabbit, and look at them and compare their DNA with the baby rabbit. See if they match up, just like on, CSI on the TV show. But I also had to look at that other male rabbit that got in there and look at his DNA. And if I go ahead and take DNA from all of them and compare them, I should be able to tell who was the real father of that baby rabbit. So let's take a look at how we would do that. Everyone in front of them should have some strips that kind of look like this. And there are 5 strips. One is a standard, one is the mother, one is the husband, one is the suspect male, and then we have the baby rabbit. I'll go ahead and do it, the analysis for you just using the standard strip. You guys go ahead and do for the other one. So let's look at the standard strip. Well, you can see that there are 3 pieces of it, 1, 2, 3, just like I've indicated right here. And what we need to do first of all is cut them out, and then you need to tape them together. So if you look right here at the strips, here would be 1, here would be 2, here would be 3. Go ahead and cut them out and then tape them together. So on strip 1, you'll cut this one out here, and then you see it ends here at the number 2. So when you cut out this strip here, you will tape this right end to this left end. And then you'll have a big strip, and you'll cut this one out here too. You see how it ends on number 3 over here? So when you cut that out, you'll tape it to the beginning of number 3 over here, so that you'll have one entirely long strip. And if you do this correctly, it should start here, right? Go through the whole thing, and it should end up right here. So go ahead and cut that strip out. And don't forget to label this one as standard. You can either include the standard part right here on it, or you could just write it on the back, but you're going to have 5 strips at the end, so you don't want to forget who is who. Once you've got that done, you should have a really long strip that should look something like this. Couldn't get it all on the same piece of paper, but let's take a look. So it starts all the way here at 1, and then I've gone and attached all the strips together, and it ends way over here. Now, what we want to do is get ready to cut this piece of DNA because it's really long. So what you're going to do is you're going to locate every place you see GGCC. GGCC, and there should be quite a few of them. So let's just take a look. Here's the standard strip. Here's the first place I see it right here. Do you see how it says GGCC right there? So there's our first one right here. Then you go through and you keep locating more and more. There's another one right there. There's another one. There's another one. If you go through it correctly, I believe you should see that there are 7 of them. So go ahead and locate all 7 of them on that standard strip. Okay? Now, if you do that correctly, the next thing we're going to do is we're going to cut it into little pieces. Every place that you saw a GGCC, and there should have been 7 of them in that standard strip, you're going to take your scissors and you're going to cut it. And where I want you to cut it is right in between the GG and the CC. So you see how I put a green arrow right here? Cut right in between the G and C on all those. So let's take a look here. So here would be our first one. We'll cut right here. And we'll continue on. Here was another GGCC. We'll cut again. Here's another one. There should have been 7 of them, right? And if you do this correctly, if we had 7 of them and you cut them all, you should end up with 8 pieces of paper. These are called DNA fragments. Now what I've done is I've taken all 8 of them and I've lined them up here in order of size. The biggest one here, I counted, actually had 20 bases, 20 letters in it. If we do this correctly, we should have another one here that should have 18. This one should have 16, 14, 12, and so on down the line. Now what you want to do is take that big piece of paper, did we use a 14-inch or a 17-inch? Put it down there landscape style, and take your 8 fragments of the standard, lay them out in order of size, give yourself a little space in between them there, and then tape them down. And you can just take one piece of tape and tape the whole thing down. So if I just had one long piece of tape, right, I might be able to just tape it down like this, and they would all stay there. But give yourself some room. Now the reason why this is called a standard is because this is the DNA we're going to use to compare. We know what the sizes of these fragments are going to be. We know that they're going to be 20, 18, 16, 14, 12, and so on, because we bought it from a store and they told us that. Great. Now you're going to do exactly the same thing with the other guys, with the mother, the father, the husband, and the baby. Tape all those strips together, locate the GGCCs, cut them into little pieces, and then put them next to the standard, so you'll have other columns. So let's say the next column would go here. This might be the mother, and then I'll do the father, and so on. I'll do them all down there on the piece of paper. And you'll spread the fragments out, and you want to match them in sizes. So let's suppose I do the mother, and I had a fragment which was 16. I would end up putting it here. And suppose I had one that was 12, I would put it here, and so on down the line. And this gives me a DNA profile for each of the rabbits. Now suppose I did the husband. Let's suppose this is the husband right here, yeah? And suppose I found that he had one that was, 18, so that'd go here. Suppose I said he had one that was 15. Well, that'd be in between, and I'd put it right here. And that way, the standard can be used to figure out all the locations. Now, if you match up the DNA profiles of the child should have part of its fragments from mother, obviously, and should have the other fragments from one of the fathers. And we don't know if that's the husband or the suspect. But there's one more problem. Size is not the only way to tell the difference here. What we have to do is something called radioactive labeling. So I'm first of all going to clear off my screen a little bit, right? We'll get that out of the way. Let's get this out of the way here too. You want to go ahead and take the size fragments and radioactively label them. And that's where the name, where's the cat and the rabbit from. So every place now that you see CAT, cat, you're going to put a big red X on it as if it was radioactive. Now the standard was not only bought because of size, but because every single fragment has a cat that we can radioactive label. Let me show you what I mean. Let's go ahead and take some red ink here. There's a cat right there. So let's put an X over it. There's another one. Where else? There we go. There's another one. And if we go through all the fragments, they will all have radioactive labels. When you get the mother, the father, the husband, and the baby, their DNA profiles, go ahead and put red X's over every place you see a cat in them. And then go ahead and compare the baby, the child, with the two fathers, the husband and the suspect, and decide which one it came from. If you see a piece of DNA fragment which could not have come from one of the two male rabbits, well, then you know who the real father was. And this is exactly how they do CSI. Where's the cat in the rabbit?